Today we're going to be going over Chapter 1 exam review for Algebra 1, 2 at Wilson High School. So please have your practice test out. I hope you guys can hear me clearly. I did a test run and it sounded okay. And again, my name's Mr. Dees. If you have any personal comments about it that you think might be helpful, please feel free to contact me via email. Also, there might be some background noise as we get used to this technology. I hope not. But again, that's something you can let me know about. Let's go ahead and get started. The first problem here says negative 20 equals 17 plus a. And as you've probably been instructed, the goal is to isolate the variable. And that's a fancy way of saying get the variable by itself on one side. And what's really important is that we're going to have to remember this idea of equality. And what that tells us we have to do is the same thing on both sides. I know you've heard your teacher say it. So I'm going to draw a quick picture right here. Let's say we had a scale that was balanced like this, and over here there were 2 marbles and over here 2 marbles. Well, if I add 1 marble to this, it's now going to be imbalanced. It's no longer equal. So in order to keep it balanced, and here's where your teachers probably have said, you need to do the same thing to both sides. So when I added 1 marble to the left side, to keep it balanced, I have to add 1 marble to the right side. Okay? Alright, so let's go to this problem now. It says 17 plus a, and I need to somehow strip away this 17 from a. Well, if 17 is there, I could just take it away from the right hand side. And when you take away 17 minus 17, it's gone, and we're left with a. The problem is now it's imbalanced. If I remove 17 from this side, it's no longer equal. So I also have to remove 17 from the left side. Whatever you do to the right, you got to do to the left, and vice versa. So now the question is, what is negative 20 minus 17? Now in a recent algebra meeting, I overheard them say that you can use a calculator. So, you know, I don't know if that's true across the board, or if maybe I misheard it. You should definitely ask your teacher. But if you can use a calculator, you might as well use the resource that's provided for you. But I will just say that if I had negative 20 and I also have negative 17, these two are working together to make more negative. And the way you would figure that out is by adding them up. So 0 plus 7 is 7, 2 plus 1 is 3. That would be a total of negative 37. And now look, guys, we're all done because a is by itself. Another downside of this video and the way we get going on it is that I can't do anything about interruptions. So if somebody walked in or there's a phone ringing, I don't know how we're going to deal with that. So let's move on to number 2. Let me adjust the brightness here just a little bit. Number 2, 9x equals 108. So on this time, you'll notice it says 9x. Now what you've been taught, hopefully, is that when you see a number next to a variable, or a coefficient in a variable, that means multiplication. And we always have to perform the inverse operation, the operation that will peel away the numbers from the variable. So like over here, when we did this, I had 17 being added to a, so I subtracted, because that's the inverse. That's the additive inverse. Here I have 9 times x equaling 108, so I need to peel that away. And of course the way I would peel away multiplication is by dividing. Those are inverse operations. So 9 divided by 9 is 1. And just to be thorough, I'm going to write 1x. You don't have to do that. 108 divided by 9. Oh, lucky me. I had a teacher that made me memorize my times tables. So that's 12. And so really, in a way, we could be done. Many of you know that. But really, I just want to be thorough. 9 divided by 9 is 1. But what's 1 times x? Well, that's just x. And so, yep, the variable's been isolated, and we have our answer. Now, I didn't do it on the last one, but you can on this. You can double check your answer by taking this 12 and plugging it back in for x. So let me go ahead and do that. 9 times 12 is, in fact, 108. Check. It equals what it should. Okay, let's go on to number 3. Number 3 says negative m divided by 7, or negative m over 7. Now what does this bar mean right here? Let me hear it from you all. Right, division. So the inverse of division is multiplication. So I need to multiply by 7 on both sides. Why would I do that? Because now multiplying by 7 and dividing by 7 cancel each other out, so to speak. They are inverse operations. 7 times 12 is 84, and that equals, now if I just write m here, oh what a shame, because it says negative m. Okay, so we got to be careful to not just leave something out, either because we don't like it or we forget. But moving on, what does that mean? Well, really what that means is negative 1. I'll be very thorough on this one. Negative 1 times m. So there it is, negative 1 times m. So how do we peel away multiplication? We divide. We don't add. We don't do the opposite of negative 1. We always do the opposite of the operation. Okay? So this is negative 1 times m, so I'm going to divide by negative 1 on both sides. And over here, negative 1 divided by negative 1 is 1m. And 84 divided by negative 1 is negative 84. And there we go. It's a beautiful thing there, and you can double check your answer by plugging it in right here. And I'll do that on occasion, I just won't do it every time. Number 4. Negative 6 equals 2w plus 22. This is a two-step process because there's a 2 we got to get rid of and a 22, not necessarily in that order, to get the w by itself. Okay, so what I like to do, and this is maybe not the best way to do it, but it kind of works for a little while, is to say who is more intimate or more tightly, aligned with w. Who seems to be a better, if you want an analogy, a better friend of w, 2 or 22? Well, I would say 2 is, because they're like really stuck together. So this is kind of like something that we can get away easily instead of breaking up these friends, which is going to be a little harder to do. So I want to hear it from you all out there. What is the inverse operation of adding 22 if I want to get rid of that? And I think I can imagine you all saying subtract 22 out there. I hope you did in fact say that. So 22 minus 22 is 0, so those go away. Negative 6 minus 22, well remember, they're both negatives, so they're working together to make more negative. 6 things and 22 things would be 28, but since they're both negatives, they're obviously making negatives together, negative 28. And over here, we just have 2w. So now this says 2 what? Plus w? No. 2 times w. So how do we undo multiplying by 2? We divide by 2 on both sides. 2 divided by 2 is 1, which is not needed to write. And negative 28 divided by 2? Well, 28 divided by 2 is 14. And a negative divided by a positive is a negative. Okay? Woohoo! Negative 14. Let's just double check that answer. 2 times negative 14 plus 22. So you just plug this in for w right there. And that's what I've written right here. I'm going to type it in on my calculator or just do it by hand. Negative 28 plus 22. And negative 28 plus 22 is negative 6. Check. It equals what it should. See that? So it's like I could go home and tell my parents I know I got number 4 right. It's like not even guesswork. It's not like I think I did. It's like I know it. I got the right answer. I checked it. I'm done. Moving on here. Number 5. Here we have a proportion. Now again, I don't know how your teachers went about explaining this to you. There's lots of ways we could go. But it turns out that when we have one fraction equal to another fraction, we can cross multiply. So what that means is we need to multiply these two, or we can. 5x times 8, well, I'd multiply the 5 and the 8 to get 40 with an x on it. And then I would cross multiply this way here. 1 times 10 is 10. And now we could set those two things equal to each other. So continuing now to get x by itself, it says 40 times x equals 10. I just need to get x by itself, and how would I peel away, so to speak, 40 times? I would divide by 40. So x equals here. Now this is a fraction, but we can reduce it to 1/4. Or if you had a calculator, 10 divided by 40 is 0.25. And so either of those answers is just right. Okay. All right. Now keep in mind there is tutoring. I don't know how long we'll have this privilege, but there's tutoring in 0 period in room 260 on Tuesday to Thursday, or Tuesday to Friday, and after school in room 203 from Monday to Thursday. So come on in. All right, over here now. This one here looks like it's got a few steps, but you can see that we have like terms here on the same side that need to be combined. So you know what I'm going to do? I'm going to be a little bit more precise there, because the negative goes with the 10, and so that's not a like term on the right hand side here. So what is negative 8n plus 3n? Well, notice the variable doesn't change. It's still n. It's like adding 8 bananas and 3 bananas to be 11 bananas, except we have a negative here. So negative 8 plus 3 is negative 5. And then the minus 10 isn't changing for now. So now we're back up to like number 4, right above where I'm at right now, where we have a two-step equation. Get rid of this guy first, not this one that is very close to n. So how do I peel away subtracting 10? I add 10 to both sides, and here I get 25 equals over here negative 5n. And now I'm multiplying negative 5 times n. So how do I peel away multiplication? I divide on both sides by negative 5. And over here, these cancel, and we get n. And over here, 25 divided by, well, what's 25 divided by 5? Well, that's just 5. And then a positive divided by a negative is a negative. And those are things that, you know what, there's an explanation that kind of makes sense of it, but you just really need to, practice that and memorize it. You know, there's certain things that you just need to memorize in order to be successful, really, in any subject, not just math. Okay, number 7. There we go, number 7. I have to turn around and look at the screen as it's projecting in order for me to see what you guys are seeing. So, all right, great. Now, this is our first experience of having a variable on both sides. We have x's on both sides and constants, or just plain old numbers on both sides. So I'm going to take my time on this one. I like to get the variables on the left. And so if 5x is unwanted on the right-hand side, how would I get rid of 5x? Well, I would just remove it, right? And the way you remove something in math is by subtracting. So that's gone. 5x minus 5x is 0, so that negative 38 is still over here. And over here now, 9x's minus 5x's is 4x's, and then minus 10. So now right now we're back up to number 4 and number 6, right? Two-step equation. We get rid of the little tag-along number first. Gone. So that's 4x equals. Now over here, this is a sad thing that happens a lot. Students will know how to do the algebra steps, but then right here, they're just careless, or, just kind of like, you're not being careful with the numbers. Again, if your teacher lets you use a calculator, my recommendation is to do it. I mean, you should know how to do this, but you're here to get a decent grade and all that stuff. But it's just something you have to practice a lot in order to get it. So here we're adding two numbers of different signs, so they're fighting against each other, and that's like subtraction, right? So 38 minus 10 is 28, but then of course the bigger number is going to win the fight, so it's negative. So you can go back and rewind and watch that again if you want. but I kind of just broke you off how to do adding and subtracting integers when they're different signs. Well, now it's 4 times x, which is needs to be peeled away, so we're going to divide by 4 on both sides. So x equals, now here 28 divided by 4 is 7. A negative divided by a positive is negative. And you can double check that answer if you wish. I'll probably wait and check the next one. Number 8. Number 8 we have just looks very similar to 7, right? But we have those numbers outside the parentheses, and so we're just going to get rid of those real quick in one step, and then we will be back to what number 7 looked like. So how would I do that? I'm going to, numbers outside of parentheses means multiplication, so I'm going to distribute the 10 and distribute the 5. That's probably the way your teacher said it, but you could just say you pass them out. But you got to remember that you're doing multiplication when you do that. Okay, so 10 times 12 is 120, minus 10 times x is 10x, and here 5 times 2x is 10x, and then 5 times negative 8 is negative 40. So now you can see we're back at number 7, variables on both sides. Let's get all the variables on the same side. I like to just keep it simple by getting the variables on the left. So I'm going to subtract 10x, so just negative 40 is over here. And on the right, if I had 10 of something and another 10 of that very thing, like 10 negative chips and 10 negative chips, then I would have what? Well, 20 negative chips. And then the 120 is still just hanging out. Okay, now we're back up to, like, you see it's very systematic. It's like number 4 and then number 6. Okay, a two-step equation. First we peel away, not 20 because they're tightly knit together. We peel away this guy like that, and that's negative 20x. And on the right hand side, if we have 40 negative chips and 120 negative chips, then that's 160 negative chips. Now this is a good opportunity for me to discuss a common mistake, and I hope you don't do it. You see the negative 20x there. What a lot of students will do is they'll say, oh, that says minus 20x, and the opposite of subtracting 20 or minusing 20 is adding 20. What you're doing there is you're taking the opposite of the number, not the opposite of the operation. It cannot be emphasized enough. You have to do the inverse operation. So this says negative 20 times x, and the opposite of times is divide. So I'm dividing by negative 20 everywhere. So these cancel out, and over here now we have 160 divided by 20, which is 8, and a negative divided by negative is a positive. Boom. Okay? Love it. And guys, it just feels so good, you know, when you're doing these right and you feel like you studied and you put out effort and you're successful and nobody's riding you at home and all that, right? So, good stuff. Okay, let's go try number 9. It says solve for y, so we need to get y by itself, and justify, each step. I feel like you sometimes. Sometimes I feel like algebra is a little boring, but that's my bad. Okay, so let's go ahead and get this y by itself. Notice the 3 and the y are very intimately connected, and so that makes 6x the tag along. We always subtract the tag along away. Okay, so these go away because 6x minus 6x is 0. 6 of anything minus 6 of that same thing is always 0. What's left over here on the left is negative 3y, and on the right, these are not like terms. You cannot combine the 18 and the 6 in any way because they are not like terms. So I just write down what I see, 18 minus 6x. Some teachers may want you to reverse those, but there's no necessary reason why you would need to do that, so I just don't do that. Okay, now what do we have over here? It's negative 3. Is it plus y? No. Is it subtract y? No. It is times y. So we divide by -3 there and there. So these cancel out, and we get y equals. Now, technically, this is a correct answer. But whenever you have one number, I call it a monomial, under two separate ones, called a binomial, then you can do division. So, in other words, what's 18 divided by -3? Well, that's -6. And what's -6 divided by -3? That's +2. But we got the x back on there. And yeah, that's tough stuff, no doubt. But the y is by itself. Oh, you know what? I forgot to justify each step. So let me go back now and fill those in. Here I subtracted on both sides. So this is the subtraction property of equality. Then what did I do? Well, I divided by the -3. And so that was the division property of equality. So that's step 1. That's step 2. Now step 3, you can't say the division property of equality because that says you do something on both sides, which I did here and here. But here I'm just dividing the -3 in, and so that's simplifying. And that's actually a justification there. So there were 3 steps to this. 1, 2, 3. Okay, next, solving for x. Notice a and x are like #1 pals. They're stuck together like glue. So we're going to get rid of the -b first. And how would you get rid of -b? Let me hear it. Oh, that was good. Good job. We add b to both sides. Of course, mine looks like a 6. So ax equals over here. Are these like terms? They definitely are not. So it's c plus b. Okay. What did we just do? We did the addition property of equality. Okay. So that's step 1. Is x by itself like we need it to be? No, it's not. So I need to get it by itself here. What is a doing to x? How are they combined? They're combined by multiplication. So I divide by a everywhere. A divided by a is 1. And so now over here, x equals c plus b over a. So that was the division property of equality. And now we cannot do this last step that we did over here because there's no way to simplify it. If they're all just different variables, well, that's lucky. It looked more complicated, but we're actually luckier because there's no simplifying that can be done. All right, I wish I could pause it and take, a bigger drink of water, but so I can't pause it unless I can somehow get some techie out there to combine different clips of video. So we'll see if we can get that eventually. So let me read this here. Given these two things, all right, I don't need to read that, compare the equations, explain and show the difference between the equations, explain how the steps are different in solving each equation. By the way, I'm doing this on the 2nd floor, no AC, and on that terrible Tuesday that was, it's practically 100 degrees, so you got to excuse me getting some water here and there. All right, compare the equations, explain, show the difference between the two. Well, that's kind of tricky. I don't know exactly what your teachers would be going for here. I can say over here that, see how the 3m and the 8m are on the same side? So what we would do here is combine like terms, but over here we wouldn't do that with those. So on the left we can combine like terms, not the right. Does that look like chicken scratch? It's a little messy. You guys got the point. Okay. All right. Now it says that's an explanation, but what about showing it? Well, I think what we're getting at there is, how do I know for a fact that the two equations are different? Well, to do that, I'm going to have to do a little bit of work, right? So what I'm going to do is combine these like terms, and I'd have 11m plus 8 equals negative 7. Now, what would I do over here? Well, since there's variables on both sides, I would subtract 8m from both sides, right? And these would cancel. So what's 3m's minus 8m's? That's negative 5m. And then plus 8 equals over here negative 7. Now this is interesting. This shows we really have enough to show that there's a difference, because here you have 11m plus 8 equals negative 7, but here you have negative 5m plus 8 equals 7. You know, you can't have all this part be the same, these parts are different, and expect m to be the same thing, or the equations are different. I think that's really enough to say. This one, what's equal to negative 7? 11m plus 8. Over here, what's equal to negative 7? Negative 5m plus 8. So they're different based on that alone. Explain how the steps are. Well, that's right here. We had to combine like terms, but on the right, what do we have to do on the right first? Get both variables on the same side first, right? So sometimes you'll need to write a complete sentence, but little arrows and stuff like this can help explain what you mean by something to your teacher. All right, good. On to the next page. Persevere. Okay. All right. The measures of two angles of a triangle are each 4 times the measure of the third angle. What's the measure of the third angle? What's the measure of the other two angles? Oh, excuse me. All right, so let's just, I think what they're saying here, I'm not drawing this triangle to scale. So here, if I had an x and an x, these two are the same. And what are they? They are 4 times the measure of the third angle, y. Got that? So each of these are. So x is 4y, the other x is 4y, right? But what adds up to be a full triangle? Well, probably covered by our teachers, is the fact that a triangle has 180 degrees in it. So let's go ahead and add up these three angles. X plus y is 180 degrees, right? But each of these x's, see, we can use substitution right now. If x is 4y, I can replace this x with 4y. And I can replace this x with 4y. This y isn't changed. There you go. So now I have 4y's plus 4y's plus 1y, which is 9y, equals 180. And now I can solve for y. And this is 9 times y, so I need to divide by 9 on both sides to get y by itself. 180 divided by 9 is 20. Boom. Now what did we just find? Well, we found y, which was that third angle right there. So that's the answer to that, the third angle. But now it says, what's the measure of the other two? So if x is 4 times y, then that's 4 times 20, right? Because that's what y is. I could just substitute in 20 right there. 4 times 20 is 80. Boom. That's what x is. And now I can double check. What's 80 plus 80? 160 plus 20, 180, like it should be. So we know we got it right. Yep, Mom, Dad, that's another one right. Okay. All right. Next, book fair. Oh yeah, do they have those anymore? I don't know. I guess maybe you could just do a phone fair nowadays. At a book fair, a tote bag costs $5 and books cost $3.50 each. If you spent a total of $22.50 before taxes, how many books did you buy? Huh. Well, I think on this one, what we're going to have to do is some guess and check. Right? Basically what we have is this. $5 for a tote bag and $3.50 for an individual book totaled $22.50. Okay? So 5 for each of those plus $3.50 for each of those is $22.50. Now, we need to basically try some values for T and B to see when we end up at $22.50. So, if you spend a total, yeah, this is interesting because I mean I can do the problem. I know that sounds bad, but what we have another component of information here that would allow us to do the problem a little bit easier. Okay, so here we go. Let's try 0 tote bags. Well, then the question is $22.50, this would disappear, right? If there was 0 tote bag, 5 times 0 is 0, so it's gone. I'm going to just use a calculator. Okay, I would trust that you guys could do that. And that is to see, does $22.50 divided by $3.50 evenly? The answer is 6.4. So it is not, it doesn't divide evenly, and so there's no way that this is an option for tote bags. Okay, so let's go try 1 tote bag. So how much would that cost? 1 tote bag. 5 times 1 is 5. So now I would, let me just do this the long way first. I'm going to subtract 5 over, and I get 3.5b equals over here, that's going to be $17.50. So now I need to see if this is a possibility, meaning I need to get a whole number of books, right? You can't get like 2.1 books, so I divide by 3.5 on both sides, and I'm hoping that this is a nice whole number there. So let's try it. 1750 divided by 3.5, 5. Oh my goodness, it worked out pretty early. So it turns out with 1 tote bag at $5, there'd be enough left to buy 5 books, and that would total $22.50. So there's our answer. But notice it actually goes back and says, how many books did you buy? So which of these was books? B, of course. 5 books is the answer. And that, my friends, is pretty tricky. Okay? And now finally, define absolute value. Show the definition by giving several different examples and graphing them on a number line. Well, oh man, help me out now. Probably should have looked at this beforehand, but the way I remember absolute value being defined was basically this: the distance between a number and 0. Now, when I say the distance, I don't mean inches, but it's a manner of saying the amount of spaces between the number and 0. Okay, so for example, let's do some of these. Let's go. 0 is obviously super important. I'll do 3 examples here. Let's take the number 2. 1, 2. How far is 2 from 0? Well, I mean, you might be going, really? It's 1, 2. It's 2 spaces away. So what that means is the absolute value of 2, written like that, is 2. Okay. Let's put a little divider in here. But what about this number? 1, 2, 3, negative 3. So the question is now, what's the absolute value of negative 3? Well, what's the space? There are 2 spaces over here, but over here, 1, 2, 3. So the absolute value of negative 3 is 3. And the reason why is because you can't have a negative distance. Alright, here's a tricky one. If I put, here I'm going to put a dot where those should have been. If I put a dot right there on 0, how far is 0 away from itself? Ooh, tricky. Well, it's not away from itself. There are 0 spaces between 0 and 0, and therefore the absolute value of 0 is 0. Okay, well hey, once again, it's been a pleasure being with you. Watch this again if you need to. Click around, refer your friends. Hopefully we'll be doing this all year long. Best wishes to you guys. Good luck.